And this happens to be one of the variable options. This is a pop-up. Take it apart and take a peek at it for a minute. Again, the filter, down internal, very large filter. And that filter will take years to plug up unless you have really contaminated. If you're off city water, the little flecks of rust that are going to get off city water is going to take a long time to ever plug one of those filters. And here we have an adjustable arc, so anywhere from 0 all the way up to 360 degrees. We can just turn it around and it just increases the arc. So variable arc. Nozzle, they call them the van nozzle by some manufacturers. Very effective, very handy for the end user. So if you're going out there and putting in sprinklers, you can put all the same nozzle in because you're just going to adjust it to whether you want it a half circle, a quarter circle, a 15 degrees, 85 degrees, whatever it takes for the location that you're in. Different heights of pop-up. We can get them all the way up. This is about a 6-inch pop-up. We can get all the way up to 12-inch. They make them as high as 12-inch pop-up. They also make in rotors. You can get 12-inch pop-up in rotors as well. Any question on the sprays? Full circle turf sprays, about 6 gallons a minute will be the upper end. There's some that'll go as much as 6 gallons a minute. And about 20-foot throw. So we can get some pretty sizable flow rates out of those spray heads. They're putting a lot of water out. In ag, we're trying to do just the opposite. We're trying to get down and into those lower flow rates so that we can have real good water penetration. And so we really reduce the nozzle size for those. We have looked at spinners and sprays on those real low flow rates that some people will call drip. But true drip is where we literally have the water dripping out of a point, an emission point. I call those micro systems micro spinners, micro sprays. Now we'll talk about true drip. And drip is where we emit water directly out of one point. And so we can get an emitter with just a little button on it, an exit point on it. Now we take one of these emitters apart, we start to find out what they look like inside, and we call them emitters. In this case, we're looking at emitters. Generally, pressure range, you know the exit pressure is going to be 0. You need about 10 psi on the front end, and you can go up to about 50 on the pressure compensating styles and they'll still work. Because lots of times we'll have a location where there's lots of elevation and you'll start at the high end of the field and the line goes downhill and you'll gain a lot of pressure just due to elevation. And so you have to go to a compensated style emitter. Whereas if you're on relatively flat terrain, you can use the non-pressure compensated style, and that removes any moving parts. The non-pressure compensated obviously going to be the cheapest because you don't have to have any kind of a diaphragm in there to regulate the pressure. The flow rates generally they're 1/2 to 2 gallons per hour. And in this, inside of these emitters, and you can look and find that there is some kind of a tortuous path. So the water has to come in through the barb that's stuck right into the pipe, comes up, hits the center of the hole, then has to work its way all the way around that tortuous path. It comes around the edge, has to work its way all around the tortuous path on the other side before it can drip out the hole in the center of the outward side. So it really has to go through quite a labyrinth to get where it wants to go. This is what we call a non-pressure compensating style, because there is no operating device in there. All it does is it just has to make that path. It has to go through that labyrinth. And what that does is it started at 10 psi at the front end. By the time it gets out here to drip out, it's at virtually zero pressure. Has just enough pressure to go out. And it'll just go drip, 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 drip.
More, though, going out?
No. You're eating up the pressure by friction loss. So you're eliminating pressure.
Do these sit just right on the ground?
They can sit sideways. They could sit straight up. They could sit straight down. They generally will be laying right on the ground, or you could even bury them. That is a possibility. The trouble is, once you bury it, you cannot observe it. So most often this will be put right on the ground and you can watch it drip. And preferably on its side or straight down. If you put it straight up, as it comes off, the water will gather and go down the pipe, and it won't necessarily drip exactly where you wanted it to if the pipe isn't touching the ground. If the pipe's on the ground, then it can be in any direction. And ideally you want to be able to see if it's operating. So on its side is generally the best, but it's not always possible.
So how long do you have to run them since there's not very much pressure?